Okay, hello everyone. Welcome to day 4, permutations of subsets. And we're going to be able to find the number of permutations from a subset. So yesterday, this question, our warm-up, will be a little bit of a review. We're going to evaluate what essentially is the same thing as saying 7 factorial over 5 factorial. To do that, we can just cancel out these because we know that 2 divided by 2 is going to be 1, and the same goes for the 5, 4, 3, 2, and the 1 as well. You're left with 7 times 6, and that just equals 42. So that's what this whole thing is going to end up equaling. Now for number 2, so we have 4 people, Sarah, Emma, Will, and Jerry. And how many different ways can they sit in a row? Okay, so let's say we have our 4 spots. So we have first, second, third, and fourth. Okay, so for our first chair, we haven't picked anyone yet, so we still have 4 choices. And then for our second option, let's say we pick Sarah for our first Sarah. So I'll just say Sarah. Now for our second chair, we have 3 more remaining options because we already picked Sarah. Let's just say we picked Emma there. Now we still have 2 more options for our third chair because we've already selected Sarah and Emma, so we have Will and Cherry. So let's just say we picked Will. And then for our fourth chair, there's only 1 more option, Jerry. So we're going to take 4 times 3 times 2 times 1, which is the same thing as 4 factorial, which is the same thing as 24. Again, if you want to pause that, rewind it, feel free to do so, but we're going to keep moving forward. Now it's the same question, but instead of the 4 chairs, we still have 4 people. Instead of 4 chairs, we have 2 chairs now. We're going to make a tree diagram. So let's say our first chair, second chair, we get to pick Sarah, Emma, Will, or Jerry. And for a second one, we can either pick Emma, Will, Jerry, because we already picked Sarah, so we're not going to have Sarah as an option for our second chair. We're going to keep doing that same pattern through. Sarah, Emma. We're not going to pick Will because Will was already sitting right here. We have Jerry. And last we have Emma, Sarah, I forgot Sarah, and Will. If we count all those options up, we have 3 here, 3, another 3. There's 3. These markings are just the grouping. It's not writing out 3 twice. It's not 33. We have 3 down here too. So then we have 3 plus 3 plus 3 plus 3. That's going to get you to 12. And another way of doing this is what we're about to be teaching you guys, is that a shortcut is kind of similar to what we were just doing, where we have that first chair and our second chair here. And we're doing the same process, where if we haven't picked anyone, we still have 4 people to choose from. And then for that second chair, we have 3 people because we already picked one. And 4 times 3 is 12. So I just made that tree diagram to help you guys reason through it. But essentially, this is what we're going to be moving towards in the next pages to come. So permutations of n objects was just n factorial, but permutations of n total objects with r objects taken at a time, we're selecting from a subset, that is now this equation here. So you're going to see a lot of these 3 things here. So you're going to want to make sure you write all these down and what n and r stands for. So make sure you composite. So n, total number of objects. For that last problem, our total number of objects were those 4 people. So I'm just going to write down 4 people in this case. And then our r was the number of objects taken at a time, and those were the 2. We were choosing 2 people because we had those 2 chairs. So our r was 2, and our n was 4. Okay, so again, you're going to see it in this way, and you can do this on Desmos or with certain graphing calculators or science. I don't know if scientific calculators can do it, but I know graphing calculators can, like TI-84s and whatnot, but you can do it on Desmos as well. Now, we will be doing some computation. So we know that it was n factorial over n minus r, because this is just what was written on the first page right before this. So we know that n, this is in the n spot, and the 3 is in the r spot. Again, it refers back to this page here, npr, right here. So I'm going to write, our n was 5, so I'm going to write 5 factorial over 5 minus 3 factorial, which is the same thing as 5 factorial, over 2 factorial, because 5 minus 3 is 2. And when you calculate that all out, we will just be writing 5 times 4 times 3, because 5 minus 2 is 3, so you're only going to write down the first 3 numbers of 5 factorial, and that gets you to 60. We do that same thing down here, so we have our n, we have our r, so we have 6 factorial over 6 minus 3 factorial, so we have 6 factorial over 3 factorial. 6 minus 3 is 3. And then you're going to write down the first 3 digits of 6 factorial here, because 6 minus 3 is 3. So we have 6 times 5 times 4, which is equivalent to 120. So that was just how you could, and you can just type that into your calculator too. But this is another way of how we would do it by hand without a calculator. Now we're moving on to the next slide. It says, how many different ways can a stylist arrange 5 vases from left to right in a store display? Okay. So let's find out what our n equals and what our r equals. Okay. Well, we have 8 total vases, so 8's going to be our n. There are 5, that's how many we're picking from. So if we have 5 different slots here, vase 1, vase 2, vase 3, vase 4, and vase 5. This is very similar to what we just did up here with that chair problem. So for that first vase, we still have 8 spots, so or 8 possible vases that could go on that first spot there. And then again, as we move over, it goes down by 1 each time because we've picked another additional one to be placed. So we're left with 8 times 7 times 6 times 5 times 4. And that is going to be equivalent, it's going to be a larger number. That's the same thing as 6,720 after you type that all into your calculator. But again, you can also write that out as 8p5 into your calculator, and it will get you that same answer. Okay, so now this next slide is going to help us move into the next unit later to come. It said, which word has more unique permutations? We're going to list them out. So mom, we could write it out as MOM, could have OMM, we could have MMO. Otherwise, if we had, yep, those are the only different combinations or permutations we can have there. Now dog, we can have dog, ODG, OGD, DGO. Oh, we are already at more than 3. But for that, I'm just gonna keep going. Could have GOD, GD. Looks like, yep, just there. So there's 3 options for mom, 6 for dog. So we know that dog has more unique permutations. And again, we'll go more into this. This is just going to help get it in your mind for when we eventually do it. And remember, the homework quiz and homework are both on Schoology, and there's extra videos for specific types of problems. If you may need, feel free to email, or we'll have those Zoom video meetings as well, so feel free to join those and ask questions. Thanks.